Okay girls, so today we're going to be learning what's called expected value, and that just simply means finding the mean. Okay, so let's go back to what we used to learn back in year 9. Let's find the mean from this frequency table. Do you guys remember the extra column that we needed to find the mean from our frequency table? It was, if you remember, f of x. Okay, so what does that mean? It means obviously you gotta multiply the numbers to fill up the fx column. So let's do that. So 5 times 7 is 35. And then to find the mean from this, if you remember, the mean formula was the total f of x column divided by the total frequency column. So let's do that. Let's add all this up. This is 169. And if I add all of the frequency up, I get 27. So the mean from this frequency table is 169 over 27, which is equal to 6.3. Okay? The reason why I'm showing you this is because now we're going to apply similar steps to our next example here in our probability distribution table question. Let's have a look at example 10b to start it off. In a game of chance, Bethany tosses 2 coins. She wins $10 for 2 heads, $5 for 2 tails, and nothing for a head and a tail. It says find the expected value of this game. In order to answer that question, you always gotta draw a probability distribution table, which I've done. And because it involves 2 coins, you need to draw a tree diagram, which I've done here. So now let's fill this up. So starting with $0, because it's in every game you can always earn nothing. And then the next amount that you earn, it says in the question, is $5 and $10. Okay? Now let's assign the probability like we did last lesson. So in this question, it says you get nothing for a head and a tail. So that means these two. So that's 2 out of 4, which is a half. It says you earn $5 for 2 tails. So that's just 1 out of 4. And $10 for 2 heads. So that's also 1 out of 4. Now, let's just step aside for a second. In any game that involves money, wouldn't you be curious as to how much you're going to win overall or lose overall in any game? So what we're going to do in order to know that is let's find the average of the amount in this game. So what I mean by that is, let's start with that $0. Now what I'm going to do is I'm going to times it by the assigned probability. And because we're trying to find the average of all this, I'm going to now add the next amount times by the assigned probability, and the same thing for the last one. Okay? What I'm actually doing by doing this is actually I'm trying to find the average of all the amount with the related probability of each. And if you actually put all this in the calculator, you get 3.75. And what that means is in this game, overall, you're likely to win $3.75 in this game. Okay? So, now, why did I multiply them all and then add it? See how here, to find the mean from a frequency table, I multiplied the score and the frequency? That's the same thing as what I've done here. So this is like the score, and this is the frequency but as a fraction, okay? And then you add them up, because that's the same thing as how we've added all the fx column up to get the top number. And then see how here I divided by the total frequency? Well, I don't have to do that here, because I already have. Because when you're multiplying by the frequency but as a fraction, that's the same thing as you dividing by the total frequency, okay? Because see how here I've multiplied the square with the frequency, but here the frequency is already in a fraction, okay? So girls, this is basically what this formula means. If you want to find the expected value, in this case the expected value from this game is $3.75. Like I said, expected value means the same thing as the mean, and this is a symbol for mean, and we'll get into that more in the next lesson. That's sample mean, and this is population mean. Okay, so population mean is like the mean of everything. Okay, is equal to the sum of the mean times the probabilities, which I've done here. So the sum of the probabilities, okay, so I'm adding all of them up times by the probabilities of each amount. So that's what expected value is, and that's how you calculate it, all right? So let's move on. Let's look at the second part. It says, if the game costs $5 to play, would Bethany expect to win or lose money in the long term? Okay, so what that means is you have to pay $5 to actually even enter the game. So that you're already losing money right there, okay? And after you play the game, remember the overall probability is $3.75, so that's plus $3.75, okay? And if you put this in the calculator, that's a minus $25. So this is actually usually always the case, okay? When you enter a game with a fee involved to enter it, you're always expected to lose money. The probability of selling a red car based on previous experience is 35%, okay? Find the expected number of red cars sold in 1 week if a dealer sells 2 cars. So what that means is out of the 2 cars that the dealer sold, how many red cars is the dealer likely to sell? Okay, how many red cars out of the 2 cars? So because it says you're selling 2 cars, that's more than one object, tree diagram. Okay, that's always your start. So that means the probability of selling red car and not red car. That's how you need to start it off. And it says based on previous experience, this is 35%, so that's 35. Then that means 100 take away 35% is 65%. That's for the first car. And then it says 2 cars, so let's draw another branch. Okay, and let's get the outcomes and the numbers assigned to it. So obviously the first one is that times that. So I'll just quickly get the numbers. Okay, so I've got these numbers. Now let's put them in a probability distribution table. So what are the numbers that are on top? The numbers that go on top are the number of red cars that the dealer could sell. Out of the 2 cars that he sold, he could sell no red cars, 1 red car, or maximum 2 red cars out of the 2 cars that he sold. So the probability of selling 0 red cars, as we can see, would be then this number, no reds for both. So 0.4225. For 1 red car, that'll be these 2 numbers added up, which is 0.455. And for 2 red cars, obviously it's the top number there. So this is what you use to find the mean or the expected value of selling red cars. So E of X is equal to, do exactly what I've done before, 0 times the probability plus 1 times the probability. Okay. If you put all of this in the calculator, you'll get 0.7. So what that means is, and you obviously can't sell 0.7 cars, so you round that number up, so 1 red car is the answer, okay, out of the 2 cars. Okay, now let's have a look at example B now. For the probability function below, evaluate A and B given that E of X is equal to 2. So they've given you the value for E of X, okay? And to find expected value, as we know from the table, we've got to do the score times the assigned probability, which in this case is A. And then we add on the next one, 2 times the assigned probability, B, plus so on. So what they're saying is all of this is equal to 2. So it's just algebra. So let's just work it out. So this is obviously just equal to A plus 1. So what I have now is A plus 2B is equal to, let's bring that to the other side, 1. So obviously this equation isn't enough to find A and B because there are 2 unknowns. So we need another equation to work with simultaneously. Now to get the second equation, here's the technique. Do you girls remember from last lesson what the property was for a probability distribution? All the probabilities must add up to 1, remember? So that's our second equation. Okay, so that means 2 plus 0.1 equals to 1. So A plus B is equal to 0.7. So we're going to work with these 2 equations now to find A and B. So let's do it. What I'm going to do is, from here, let's make A the subject. So that means 1 minus 2B. So A is equal to that. So now let's replace that with that. So we've got 1 minus 2B plus B equals to 0.7. So if you work through all this, 0.3. That means putting this back in here, A must equal to 1 minus 2 times 0.3, which is equal to 0.4. Okay, so that's how you would answer this question. Alright, let's have a look at just 2 questions as a guide and I'll finish off. In the question, it says to find the expected value of that, and if they give it to you as a pair of coordinates, you just need to put them back in a table, okay? That you don't have to. You can just times these two, plus times these two, plus times those two, or if you just want it to be more clear with yourself, this is the same thing as writing 0, 1, and 2, and a quarter, a half, and a quarter, and do the same thing as what we used to do. Now, with question 3b, it says the sum of two numbers rolled on a pair of dice. So once again, because it's got two dice involved, you've got to draw that really long table up. But the numbers that go on top here is what I wanted to point out. It says sum of the two numbers rolled on a pair of dice. So what numbers can you get when you add two numbers on a dice? What's the smallest number? Well, to start off with, isn't it 1 and 1? So 1 plus 1 is 2. So that's the number that you would start off with. And then you work all the way up until the biggest number that you can get is 6 and 6, and if you add these up, it's 12. So that's all the numbers you would have to fill up on the top column, top row, okay? And then assign every probabilities that go with it. All right, that should be enough to get you through the exercise now. Do all of exercise 12 over 3. If you have any questions, let me know. Thanks. I have a fraction here, okay? When I multiply each of these probabilities by the... Oh, why is that part so hard to explain? Now stuff this, I can't do it.